Are we live?
I think we're live.
Hello.
Hello, everybody.
Hey, everyone.
All right. Welcome to Makercast 22 for November 1st, 2020, and the hopefully past times. I can hear myself. That's weirding me out. Sorry. Episode 22. We have with us today myself, TwinkleTwinkie, the first-time host, second time on the podcast, and Clem of Mayor Makes, Bitluni, Deshipu, Ajay, and Matou. I knew I'd get it wrong. I told you I'd get it wrong.
Matou.
There we go. So if you've not been with us before, generally speaking, we talk about the things we've worked on in the last month or so, or if they're new, like Deshipu, Ajay, Matou, they get to talk about whatever they'd like. And I don't have that much to talk about this week, so we're pretty much just going to skip me anyway, because life. But we're going to start with Meyer Makes and see what he's been doing for the last 30 days. Go ahead.
Of course, you had to throw me under the bus.
Absolutely.
So, okay. For everybody that's new, I'm Clem from Meyer Makes and also Element 14 Presents. That's the YouTube channel where me and a lot of other makers post our stuff. And in the last month, I've made a lot of projects, actually. There are a lot of videos coming up, but I can only share one because I only got one here at the desk. But first, I want to share you that I've joined the Believers and I finally got the Holy Book. And I got it even for a decent price. So finally you can start with doing proper electronics and not just fooling around and hoping stuff sticks to the wall. So yeah, let's start with actual projects. So that, I don't have the origin. Everybody knows how a multimeter looks, right? So that's not a secret. Everybody knows that. Okay. And that is my tiny mini multimeter. I call it a DMMMMM, Digital Meyer Makes Mini Multimeter. So 5 amps there. And it's like exactly the size of my full-size multimeter screen, but just in mini format. And try to make it a little bit more visible. And yeah. And this thing directly plugs into a breadboard, so you don't have to fool around with alligator clips and bigger leads and stuff. And if you turn it on, it has a screen, and it shows a value, and that is the static that it picks up, the 0.9 volts. So that's very reliable, of course. Yeah, and this thing is, I've made a custom PCB for that, of course, to get all the electronics inside this little thing. And it's powered by an ESP32S2. So I'm finally joining the ESP ranks. Like Bitluni's a pro with all that stuff, and I have no clue about it. So I finally joined the club. But I use the S2 because I tried interfacing USB UART chips to the 8266 and another 32, and I couldn't get it to work. And this thing has native USB, and it has, it's USB-C. So, I tried to play around with that and finally get my head around how to implement native USB and this new microcontroller and stuff, and to make it work with Arduino. And during the project, there were a lot of like developments with the Arduino integration. So it's now a lot easier compared to when I started. Like the first thing that I did on this thing, I had to flash it with the ESP IDF tool, which I generally hate because for some reason, I don't know if that's normal, but I have to reinstall it every time I use it for some weird reason, or it won't connect to the device. But this now shows up. I also tried out MicroPython on there, which works, but not with the components I have there because there are no libraries. And that thing is basically in there is a LiPo battery, charge controller, the ESP32S2, an encoder, so you can choose the modes like on a normal multimeter. Of course, it's had Wi-Fi, so you can get the readings on your phone over a little HTML page. and a little OLED, and the current and voltage measurement is done with a TI INA 219. So that's a I2C voltage and current measuring chip. Just interface there. And yeah, I have to give a really big warning on there, because if you're planning to use an INA 219 with your project and you're designing in KiCad, the pinouts in the official libraries are wrong. So there are only the SOIC 8 version is correct, and the SOT 26, I think it's the SOT 26 part, that has a reversed pinout. So if anybody wants to use that chip in KiCad, be aware of that. I've issued an issue, but who knows when that will get fixed.
Yeah, I think everybody, it's really just a good lesson in general that when you are putting together something and you're using a pre-built footprint in KiCad, that you really should like double, triple, quadruple check it. I don't know of anybody who hasn't gotten in trouble by just trusting it as it was, and then you get the board and you're like, oh, wait, what?
Yeah,
print it on paper first and lay out the parts if it fits.
Yeah, that doesn't help you when pin 1 is on a different thing. Like it's really like pin 8 is pin 1 and stuff. It's not like flipped or it's like scrambled. And there are for this chip, and also I had to deal with 2 other chips on other projects. There are some that have we all know DigiKey has a big library for all these parts, and they have a different pinout than on other, like on the official KiCad libraries. You take the same part and they have different pinouts. So something's wrong there. Or maybe there are multiple versions out there. Who knows? But I couldn't tell them apart. Just had to double check with the data sheets for the actual parts I got. Yeah, and because we have Jay on this episode, I tried to, because of his companion bots, I have pulled out one of my older projects again, which is this thing here. So this was originally, so it's a human head. It's exactly like life size, and it's animatronic, and that was the launch project for the BeagleBone AI that I did when it launched. And coincidentally, it came out the same day as the latest Terminator movie, but that was pure coincidence. I had to postpone that project several times.
I'm sure it's better than that movie was.
Yeah, kinda. So behind these shades are some weird eyes, and in that one, there's a camera in there. And that stares at you. The other one has just some LEDs. It's fully animatronic. I can't show you it working because I already cannibalized it for more parts. And to make it work, I need a computer tethered to it to make the code run. Because in there, we once had a comment for somebody that said it's pretty hard to finish a project that you start with BeagleBone. And in here, there's a lot of stuff in there. So like there's an Arduino Nano and a USB hub and some more boards. And the lowest one is the BeagleBone AI. That's the pre-release prototype thing. So that one has pretty much no driver support or anything in there. So that's why I have a USB hub on there, because I faked the ID for the webcam that's in the eye over the USB hub. So the BeagleBone accepts the USB hub, but not the camera directly for whatever reason. I think there are just some drivers missing. And then I had to use some very tiny wires. You probably can't see that. I'm pretty sure. Yeah, it's really tiny. So yeah, I won't even try to make that work. But there are really tiny wires that I had to directly solder to the interface chip on the Arduino to make that talk to the BeagleBone, because it won't talk to it directly over USB, but with RX and TX. So that was surprisingly difficult, and I had to make this work on time, and that was very convoluted. Also had to make a little a little cooling board for it, because at that time it did run so hot that it thermothrottled within 2 minutes and then died after 10. So it just shut down. With the cooling, that worked great. And like a week later, there was a firmware update that made it all work good and fine. Yeah. And then you have this appendix here, which is a relay board, an MP3 player module, an audio amplifier, and a microphone and a speaker. So my original intention for this was that I would have it on my shoulder like a companion bot or like a second head for myself. So I would have it like that, mounted on it, would replicate my movement, and when I speak, it should move the jaw accordingly. I got that to work, but it's just barely able to lift itself. So yeah, it's just too heavy to have it on your shoulder. Yeah. And it's a problem that some people here might know. And then the actual project for it was, how do you use these AI capabilities of the BeagleBone in there? And then I made it recognize human faces. And when it recognized the face, it turned towards. There's a full video, of course, on YouTube about that. It turns toward the person, and then it throws a Terminator quote. And that comes over that speaker, so that's what this appendix is for. Then it says stuff like, I need your clothes, your boots, and your motorcycle. And yeah, and somebody in the comments then pointed out that I basically built a thing that looks at humans, and if you change out the speaking for a gun, you basically made an automated turret. So that was a bit scary, because not the best projections for future.
Well, how much does it weigh? I mean, I'm sure it's painted, but it looks pretty heavy.
Yeah, 2 kilos or so.
Oh wow, that's a lot of weight for a wearable.
Yeah, it's a lot of weight. So that's what I still want to make a companion bot, but I think I will make a duck, like just a tiny duck that you can get, and it may, like, I don't know, the offer in there or something, like more like Wi-Fi capabilities and maybe flashing, not so much big honking electronics. Yeah, that was a bit too heavy and too big, and it's, when you see this thing moving, it's actually pretty terrifying.
Well, that's great.
It has uncanny valley vibes. So thanks for listening my garbage, and on to the next person, please.
All right, Bit, I think that's you. Tell us all about the butter.
Okay. No butter facts right now. Okay, so I announced so many cool projects that I will start this or last month, and since then I did none of them. But but I was went down a rabbit hole about a topic that was of my interest. I got, like, the last time I was in the US, I got these glasses here, these in Chroma Glasses, which support people with color vision impairity like me, to get like a better color vision. It's like a notch filter that filters the light spectrum, where you have a notch in this part where the cells that are responsible for the contrast vision are blocked, and this way you can separate the colors a little bit better. At least that's the claim. And I wanted to take a look at how the glasses are working, and I thought, okay, fine, I will do an experiment and take a look at the light spectrum and measure how the filters work. And I looked online, and the instruments that you can get there are starting, like, at least at the level that I would be acceptable, start like at $2,000 spectrometer. And I thought, okay, I saw maker projects that do this already easier. You can do it with like the mobile phone and with a diffraction grating. I can maybe show this. This is like, oh, okay, I need to turn off.
That is trippy.
sorry, oops. Yeah. I just need to turn off the green screen. Okay, this is the diffraction grating, and you can see the light spectrum there. To the left and to the right, you can see like the light spectrum is spread. This is an incandescent bulb, so you have like an equal distribution from over the complete spectrum, more or less. And if you would take like LEDs, it is not so even. And so this is like, you can get this for really cheap on eBay and AliExpress and whatever. Or you take a DVD and use it as a mirror, and this way you can spread the light, and with an image sensor you can simply record and display the intensity as calibrated. You could get the wavelength over the complete spectrum. And so I looked into image sensors. The problem is that most image sensors have a like color filter on top, like infrared, and then you have the bias filter. No, which one is it? At least I thought, okay, I take a grayscale sensor which doesn't have that, and when I was looking into that, I found, and there are linear sensors. If we get this to focus. Oh, no, that might, okay.
Oh,
so,
there you go. No, back.
yeah,
there you go.
Okay, so this is a linear filter that has only one dimension, and the pixels are quite big, and you have, yeah, you don't need to focus this precisely because you have a large space there, and you can read this out easier than like very high density square image sensors. And I got a few of these from Mauser and tried to experiment with that, and I started to stream that. We had 2 streams, and both were more or less successful. And if I switch the camera, I can show the current experiment maybe. So this is, here you can see, this is the filter, the image sensor, and this is the diffraction grating, and these are just 2 slits. So we get like, maybe I can show this with this camera. We get like a really thin light strip, and if I put something in front of, this is directly in front, and then we have, I'll turn off the lights so we can probably see this better. And there is a rainbow which is projected directly on the image sensor. So, and I got it this far that, turn on the lights again. I'm using Arduino Micro for the timings, for the clock and the timing signals. I just put some blue tag on the LEDs so it won't destroy my experiment. And I can show it on the oscilloscope. I get an output, but I'm not finished yet. So I get a response from the image sensor, which I can show. I need to turn on the digital probes here.
And at this stage, are you just trying to get a baseline of the full spectrum before you can start filtering?
So the idea is that I would get like, I built like maybe a 3D printed case that would be the regular way to do it, and then I can I will get like a response on a linear response on. Let me just trigger. I need to reset the trigger here. D3. Okay. So yeah, more or less. This is the clock signal here, and then we have some control signals which resets the pixels, and this is the response that I get. You can see here it's like inverted, and this is more or less not saturated. This is like maybe I shine a laser or take a light on the image sensor so you can see something happening. So this is when I put light on the sensor, you get some response there. But yeah, the timings have to be quite tight. I probably need to switch to another microcontroller there. But yeah, that's the current state that I'm working on. It's a little bit further than the last stream that I got this. And actually, when I'm finished, like reading out the sensor with that's only, this one has a resolution of 1,500 pixels, so you can get like 2 readings per nanometer wavelength, more or less. And then I can take probably like maybe a laser diode, so I can calibrate the wavelength with 2 different diodes where I know the actual wavelength, and maybe calibrate even the complete spectrum, normalize it with sunlight if I or with known some kind of known calibration values or something. So that's the idea behind this whole thing. And at the end, it should be like something very, very cheap that can be easily rebuilt. The sensor from Mauser, it's $8, and from like other sources, you can get it from like $3 or $4 for that one. There are even dip versions of that. This is a surface mount one, which are bigger, but they're not easy sourceable in high amounts. And yeah, not many other parts. So you get on like some 3D printed case and a $5 diffraction grating there, and a microcontroller for like $10. That should be all. And there's actually some software for PCs, which other already have written, that do some calibration stuff, and you can display that stuff. If that doesn't work, I can always write something on my own, and that uses like serial port. And I think, yeah, that's all about this project.
That's great. What is the diffraction paper typically used for? Like, what if you weren't trying to do something like this? What
Just
or typical application for it?
The typical is like science experiments. So,
oh, okay.
So you usually get, if you search for that, that's usually like marketed for physics lectures or something like that. So school projects or so. But you can simply take an old CD or DVD and does the same job. But on the diffraction grating, you have like a specific density of lines. So these are like vertical lines, and you have probably, what is the density? Maybe 1,500 per inch or something like that. So there are different densities, and you could actually count on that if you use every time the same grating, that you more or less your response will be projected at the same spot. So that's probably important to know. And if you look at the DVD, this the density changes with the distance to center of the CD.
Awesome. That sounds great. How did you? So once you got the color or the glasses that allow you to see those colors a little better, was it a big change for you? I have some friends who were colorblind in a similar way, and for them, like one of them, it wasn't that big of a difference, and the other one, it was like
no, it doesn't like cure anything, but it's like you would like what is the name? You will pump up the colors a bit.
The vibrance.
Vibrance, yeah. Especially I noticed. So when I was there, it was at the SuperCon last year. It's 1 year ago. I bought them, and it was Beverly Hills, and they gave the glasses to me and sent me outside so I can see how it is working or not. And what I noticed especially is the yellow, and it was like very vibrant, and it wouldn't cure me. So if you know, like the Ishihara tests where you have the dots
Right,
and you have the numbers, it wouldn't like enable me to see more there. But actually, I didn't try. I have somewhere the Ishihara tests, but outside it wouldn't be much better. At least because my impairment is very strong, and yeah, but it works in some way. And I would like to test the filter, so the glasses, and to test actually how good is this notch filter, how good of a filter can they produce at volume for that price and stuff like that. So that was the idea to look into.
right. Oh, that's great.
Yeah.
Well, Deshipu, that's you're up next.
Okay, hello, I'm Deshipu, and since I'm for the first time here, I'm going to show some of my old project very briefly, and then I will show what I'm obsessed right now with. So my oldest project, it's actually something I started with my adventure with electronics some 5 years ago. So it's called Tote. It's a spider robot, basically. Let me find the switch. So it's Arduino based, and the goal was to make it. I will switch it off because it's noisy. The goal was to make it as simple to make for people who don't have a 3D printer or laser cutter or any of those tools as possible. So the legs are actually made out of the servo horns, so the little plastic pieces you get with the servos. And it's all connected to a PCB, and the case is actually added later. It's not necessary. And later on, I'm working on a more accessible version that even the legs are included in the PCB already. So you basically just break off all those pieces and make a robot out of this. Just add the servos and the battery. Yeah, so it even has those little switches at the ends of the legs, so you can tell when it touches ground. So when it's nears the edge of the table, for instance, you can make it stop. The thing is, I'm still programming this because I switched from Arduino. This one, the big one, the old one uses Arduino because that was the cheapest thing you could get back then. This one uses Adafruit feathers. And I use CircuitPython for programming, so I have to reprogram everything from scratch. And that's taking a long time. Right, next thing. So it takes 12 servos because you need 3 degrees of freedom on each leg. So I thought, okay, maybe I can make something cheaper. So this is a cheaper version of that. And yeah, it only has 8 servos. It's still not programmed, and it actually has included the microcontroller, but you can still plug Adafruit feather wings into it, so it's compatible with all the feather wings. So you can add like LED matrix or a display in front. So yeah. The problem is with just 8 servos, you cannot turn easily.
Right, you just don't get the freedom of movement.
Second thing is this game console. That's also programmed with CircuitPython, so you create your games with Python, basically. And maybe it can focus. Let me try something. Maybe we can do it like this. Right. So yeah, you can have games like Space Invaders or generally simple sprite-based games without too much scrolling, because scrolling takes a lot of processing power, and then it slows down.
Which
Okay.
microcontroller is that using?
That's Sun D51. So quite a beefy microcontroller, 120 megahertz, I think, and quite capable actually. So, but Python needs to be interpreted, and even though the display routines themselves are written in C, so that makes it fast enough. And yeah, my obsession for this year is keyboards. So I made this tiny little keyboard. It actually has RGB LEDs under every key. So if you press a key, you'll get a nice animation around that key. So this is what I started with. And then I figured, okay, this is the smallest usable keyboard I can use for myself. And you can see it only has 10 columns. So you are missing a lot of important keys. So the idea is that a lot of modifier keys are on the same physical keys as normal keys. And depending on whether you press the key and release it, or press the key and press another key, they work differently. So it's also, of course, programmed with CircuitPython, because I hate programming, so CircuitPython makes it a bit easier. So I try to use it in all my projects.
Is there anybody else here who's like a big keyboard weirdo like me and Deshipu?
So I see you have an Atreus.
Yeah, this is the newer one.
The problem I have with mechanical keyboards,
3 Atreus is very nice.
The problem I have with mechanical keyboards is that normally they are about this thick.
Yeah.
And the travel of the key is like a centimeter. Well, maybe not a centimeter, but half a centimeter at least.
Yeah.
And I'm used to very flat laptop keyboards. So like mechanical switch looks like this. You can see the keycap is a big part of it. And there is quite a lot of travel for the key. And also there is quite a bit of unnecessary space wasted here. So 2 years ago, I found out about the Calif low-profile mechanical switches, which look like this for comparison.
Chucks.
Right. It even focused. Nice. Yeah, so this has 3 millimeters of travel. And the keycap is much smaller, and the switch itself is much smaller. And so the idea I had was to build the flattest keyboard I can make that is still mechanical. And initially I made like this PCB for like regular, like traditional layout of the keyboard.
Yeah,
later you can see this is damaged because I removed all the switches later on because this didn't work very well. Made a more like fancy layout. You can see those switches are even better because they even sink into the PCB. So a part of the switch is sunken into.
Is that a native part of that design, or is that something extra you did?
This is a design of this switch.
Okay.
It turned out that those switches are very crappy. Like those are great. The Calif chocolate switches are great. The Calif chocolate switches that are sunken into the PCB are super crappy. Problem is you get the click before they actually connect.
Oh, that's not good. Yeah.
Yeah, so you get missed. So you type and you feel that you are typing, but nothing.
It didn't actually actuate. Yeah, that's not good. That's not good.
So I abandoned this. It stayed like this, and made a proper version with the chocolate switches. And here you can actually see the proper, even like key labels, except for space, of course, because they don't make spaces like this. So I had to improvise. And one of the shifts is a function. Here. a function key. But otherwise, it's a pretty nice ergonomic keyboard. And I've been using this for the last week. I have some ideas for improvements. Of course, next week I will get a new PCB and make improvements. And of course, the Atreus as well.
Yeah.
Upside down. So nice thing, it's really flat. So I called it Flat Rails. And because then you don't need the wrist rest.
Right.
You can get your hand completely flat on it. And it's also good for RSI because you don't have this bend in here.
Right.
And no pressure on the nerves and so on.
Actually, it looks like my Cherry, probably the same keys I used in that. So
Cherry doesn't have low.
Yeah, but it's also very low profile. Yeah,
but is it mechanical?
Yeah. Cherry has their Coway or Kale, it's said a couple different ways, did it first, and then Cherry had a follow-up. They both, I believe, use the same footprint because they all use just the regular old Cherry MX footprint. But actually, the Kale one, I think, is actually a little more lower profile than the Cherry one is.
I see, but I know there is Gateron as well, has those chocolate.
Oh yeah, because the other thing is the Cherry low profile are still Cherry compatible, so you still use the Cherry stem.
Oh, I see. So
versus the Chalk have that the I think it's square with 2 notches in it.
Yeah, so Kale also has version 2 of those that are Cherry compatible. The problem is that because it needs to be compatible, the stem is a bit longer, and of course, if you put a huge keycap on this like this, it's still much higher.
Yeah,
right?
Yeah.
So it's still... But
that's awesome.
Quite nice. Like those keycaps are spherical. They are T keycaps, so they are pretty nice as far as keycaps go. There are some fancy keycaps for low profile keyboards as well. It's not just the defaults that they give you. Yeah, and the last keyboard I made is this thing. So I figured out, okay, I have this CircuitPython library now for keyboards, and that runs on SAMD21. So that's the smallest chip on which CircuitPython runs, basically. And I could make workshops for making keyboards to explain to people how the matrix is scanned, how you can send the USB reports, and stuff like that. But those switches with shipping, they cost about $1.
Yeah, they're pretty expensive.
That's if you have 100 keys keyboard, that scales pretty. I mean, if you buy 100, they're a bit cheaper, of course, but still, it's like $60.
Yeah.
So, yeah. And then I decided, okay, I will make them minimal one that still makes sense to have a matrix for. And it's still useful for things like, switching scenes in OBS or stuff like that. You can put any keys on those keys you want. So it can be Alt Control F1 or, volume up.
Right.
You can have media keys on this also. So that's nice. And so you get a nice, useful macro keyboard and you get to, do a workshop. Of course, right now with the pandemic, I'm not doing any workshops.
Yeah, I mean, a lot of those keyboards, because the mechanical keyboard world in general has gotten just so incredibly popular. A lot of the projects I see these days turn to products, maybe not huge commercial products, but a few hundred, maybe 1,000. Are you looking to do your thin style, because it looks like an Alice sort of style layout, and I know that's a pretty popular split ergo. Are you looking to maybe next year kind of do that as make that as like a product or a kit, something like that?
I might sell the PCBs on Tindy. I'm not going to sell the switches because that's just too much of an investment.
Right.
So I might actually sell soldered up PCBs with the microcontroller with the diodes on it already. and just that. The thing is with the quarantine and pandemic, I'm also paused my Tindy store, so not this year.
Yeah, it's
So
really rough right now.
probably, I mean, you have to order at least 5 of the PCBs. So I have spare PCBs. So
Yeah.
at least I would put that on sale.
Yeah, I would definitely check an interest in that because especially like you'd be surprised. There's so many people just starving for different layouts and different kinds of things, and there's next to nothing for low profile. Like you said, the switches are they're relatively expensive. And actually, it's not even really the switches that are the hard part. It's the keycaps. The keycaps are the real hard part to find because there's not many companies that are making them, let alone quality companies. So.
It actually improves. I recently, like 3 days ago, found a new set of keycaps, like the whole set for a complete keyboard with the labels. Keychron.
Yeah, Keychron. Yep.
Yeah. So the problem is they use the Gateron switches, so they have like small notches on those. Like,
that's a shame.
Yeah, if you take this, there are like the two. Oh, I broke it. Nice.
Yeah, well, that's the other reason why. They're relatively fragile.
One of the first ones I ordered them like 2 years ago, and they were much lower quality than the new ones. Like the plastic is much more brittle.
And then is that typical ABS?
They have small notches on those knobs here, so they don't fit into the Calif switches. But I can also dremel that out. I'm not afraid of doing that. So yes, I think that's. Oh, and I also have this Fluff M0, which is an Adafruit Feather compatible board with SMD 21. So it's pretty much the same as Feather Basic, not the Express. It doesn't have the flash thing. The difference is it uses a smaller package for the SMD 21, so it's a cheaper, smaller package, and it has literally 5 parts on it. Sorry, there's an LED. It has literally 6 parts of it on it. So it's probably the cheapest Feather compatible board you can get. And I included a lot of prototyping area on it because there was so much space left. And I just remapped the pins so that they have at least the same functions like an original Feather, but I used all of the pins. So the firmware for it, I use actually the same firmware in the keyboards because it breaks out all the pins. So I can use all the pins then from the chip.
That's awesome. That's great.
Yeah, and it actually doesn't have a USB plug. It has this. Maybe it will focus.
There it goes.
Yeah, so it basically has the USB plug is made out of PCB, so you can plug it like this.
Nice built integrated. Very nice.
Yeah, so it's even cheaper that way and even thinner, so you can actually use it as a business card. So because it's so cheap, it's about $3 if you produce like 50 of them.
Wow.
It would be like $3 per piece or something like that. And you can print stuff on it, so it could be good maybe for a swag on conferences or something like that.
Yeah.
And you get a CircuitPython capable board that you can fit in your wallet.
And what was the thickness again? Was that 0.8, 0.6?
Yeah, so that's if I remember correctly, that's 0.6. Because this is the USB micro USB version.
Right.
I also have the USB-C version. And that one works better with 0.8 millimeters because it sits in the socket more tightly then. So I have both USB-C, but USB-C needs 2 extra parts because the pull-up resistance.
Yeah. You unless you use a specific one. Yeah. Well, no, never mind. You're replacing that whole part. So yeah, you need the resistors and everything. Otherwise, could be bad for whoever plugs it in.
And also, if it's cheap, if it's made to be accessible, also, for workshops and stuff like that, then, the people who can't afford super fancy workshops also can't afford USB-C nowadays. Right. So it makes sense to use micro USB.
Deshipu, about the USB connector, is it flippable? Can you plug it in both ways?
The USB-C, yes. The micro USB, no, because then you will short the pins, because the other side of the plug is just metal. Yeah. Because then it would just short.
Did you publish the files anywhere?
Yes, of course. I forgot to say. All of my projects are on hackaday.io. So all of them are published. I use FreeSync for PCB design. I'm sorry. But at least
I like how you apologize as soon as you say that. And you should, sir.
And that at least makes it very easy for beginners to use those projects without actually learning to use KiCad or Eagle or whatever. You can just drag and drop things around, add stuff to it, and make it your own. So that's why I prefer FreeSync. I don't have to, teach people to replicate my projects.
Okay. Yeah, well, sounds great. Well, Ajay, are you ready to go?
Sure.
Right. Let's get to it.
Okay. I won't be as long because I haven't really been working on many projects this month by design.
Well, just tell about everything you do.
On my head. Oh, everything? That's a lot. I do a lot. Okay, so I usually work on wearable robots mostly. I guess that's like my main niche right now. But started COVID, I ended up redesigning the monkey behind me. So he had a totally different look at the beginning of COVID, and now he's like this now, and I have him on the corner of my desk because I use him for, well, I'm recording now because I'm finally hopping on YouTube. I haven't done YouTube for a while, and he's my co-host. So I've been doing a lot of recording and a lot of like random things to keep it entertaining at least, because I really didn't want to have a boring little YouTube channel where I'm just like, I did this, and then I did this. Ta-da. So I'm trying to go a little bit more entertainment-wise with it. So I have a sidekick. But mostly I build a whole bunch of wearable robots. This is one of my head is the current one. I built another one recently that I call Paradoxy, which is the 4th version of it, technically. I started this project a month ago, and I kept upgrading it because the Mark 1 was cool, but all it did was like light up. Then the Mark 2 was pretty great, but then it was too heavy to wear on your head. And then the Mark 3 was good, but I didn't like the design. So I finally sat down, put all my effort into it. I ended up creating this version, which they call Paradoxy, and it has like everything I want in it. It's cool, it's small, it's light, it moves around, which gives it way more life than I thought it was going to do. It hasn't been published yet because I'm still working on the files. I'm very mechanical design when it comes to stuff like this. Like, I suck at programming. I am the worst programmer ever. I could probably lie my way through an interview.
Oh, we're all lying through those. Don't worry about that.
If you tell me to sit down.
Fake it till you make it.
We all just copy
and you sit down and tell me. Yeah. Pretty much. Like, it takes me forever to do that. But like, when it comes to mechanical movement, I'm pretty good at it. Like, I can put like a single servo in my head and figure out how I want it to move and figure out how I want a robot to move to give it some like life. So like this one, since I have the second one with me right now, you can see it's just a pulley system with one servo. Yeah, I'm pretty clever when it comes to stuff like this, which is great because it makes it really light. And that was like my big thing. Something that you have to pay attention to when you make wearable robots is how heavy it is. And that's something a lot of people don't think about until it's too late. And I have experienced that with the monkey back there. because I can wear him, but I can't wear him on my shoulder. He is a backpack robot. He can be attached to my backpack and be worn like over my back to look around and stuff. So something everyone should keep in mind when you're trying to figure out where to wear your robot is like size and weight. So this one's pretty cool because I can wear it on my head. He's like super light. You can stick up on there pretty well. It looks super cool, so everyone like loves looking at him. Like I took him to work, and then like every time someone walked by me, they kept like staring at him. So it's like very interesting to have that fun interaction, which I should have recorded. Man, I need to really do some recording.
It's really amazing. So if the center area is where the all your gears and linkages are, does that mean like all the battery and everything else is in the abdomen and the butt? In the butt.
It's in the butt. Like, let's be real. We're going to be adults here. We're children. It's in the butt. It's all in the butt.
That's awesome.
I thought it was, well, I'm still working on some other stuff too, because like I am doing my best to get stuff together for like YouTube and to publish it because I'm all open source. Like I don't think I ever want to be like paid per se for my ideas. Not for like the work effort for it though, but I'm all self-taught and I've learned through the internet, through other makers like yourselves. So I always want to give back to that community that taught me so much. So I kind of have a personal rule that like whatever I really work on, I'll always make open source because of the fact of you guys taught me. I'm trying to teach you guys back. It's a repayment in my opinion. But yeah, this one I've been working on for about all month, literally. I've been trying to get a documentation together for it. So like I made the second one yesterday, but it's like 2 days in printing and then 1 day assembling because I kind of designed them like a Lego piece.
That's not bad at all, though.
Yeah, trying to make it. Yeah, like I'm definitely trying to make it more easily built for people because not everyone's gonna have the same skill as me or you when it comes to assembly. So, but everyone's played with Legos or like at least Bionicles or anything like that. So if you played with that growing up, I wanted to make it as easy to put this together as that. So I have a lot of like things I'm still working out. That's why like at the beginning of this, you heard my 3D printer going because I'm like retesting parts to make sure they fit better. Because I really don't want to have those awkward fits. Those are really embarrassing. But yeah, so this one is just like my most recent and like coolest, I think, thus far. It's just so fun just to have going. And like it just holds on so well that like I can just move around and not really care too much about it like moving back and forth. I do want to make a bigger one later and have it be on my shoulder most likely and have it do more, of course. But for right now, I'm trying to keep it as simple as I can. So right now it's just a single servo moving. It's being powered by Adafruit Trinket because it's super small. And I already have a lot of like work with the Trinket. Yeah, the smaller your microcontrollers, the easier it is to make wearable robots. The bigger it is, the more you have to worry about power, things like that. So you have to think small to make it big, if that makes any sense. I think it makes sense.
So what size battery and what kind of battery life are you getting out of it for the time being?
That's the issue. I have a whole bunch of lithium-ion batteries. They're all 3.7, about 120 milliamps of power. But currently they both are using 2 different sizes. So like I have to like set a timer one of these days and just test them. Because I do a lot of testing before I publish just because I want it to be as perfect as it can be.
Great.
So I have to do a few more tests and then I have to make one more with all the new edit parts I just finished. But then I'd be like, okay, it's ready to be published. And I can like put everything out there and not feel like embarrassed if something doesn't work.
How long does it take from start to finish to develop like a robot like this for that one on your head?
This is the 4th version of the concept. It took about a month of nonstop working, and like I'm very obsessive when it comes to like my robots. So like I'll go to work and work my like 9 to 5, and then come back and then do this. And then I'm just constantly iterating. Like even every day I'm working on something. Like I have to. It's like a weird problem. Probably just to get therapists about it in the future. But you know what? Right now I'm not going to worry about it. It didn't work on it. So I'll let it go for right now. But yeah, it took about like a month to get it this far and get this design because originally it was just one dome design, which is cool and very sci-fi-y, but it wasn't what people really liked. And then as soon as I turned it into like a full-on steampunk thing, using this copper filament, which I love steampunk, it's like my favorite sci-fi genre. As soon as I did that, everyone was like, "Oh my god, so cool!" So like, I guess is how it ended up.
That's awesome. And,
yeah.
At SuperCon, which is where I met you last year, you had I think a monkey companion then. I think that was blue. Is that the evolution of that guy? Oh, that's awesome.
Yeah. Dexter has gone through. This is Dexter MK5. Yeah, it was MK5. So I will start a project, and if I don't like it, I will keep working on it until I get to a point where I like it. So like it will go through, like Iron Man's armor is a good example. I will continue making iteration after iteration after iteration until I see that it's good enough.
Have you thought of making a steam-powered one? Since you,
I did. Fun fact.
There are these small steam engines that you can buy. The post-apocalyptic inventor just get one from like trash or something, a super small one, and it would be like really cool to have actual steam engine there that's powering like the legs probably.
I thought about that, but the main issue when it becomes stuff like that, it wouldn't be a wearable anymore because those things are heavy and a little bit dangerous. Like if you really don't want anything that can accidentally explode on top of your head.
Oh yeah,
for
true.
multiple reasons. Like I'm working on a dragon still, and dragon is supposed to shoot fire later, and I still haven't figured out how I'm going to actually have the flamethrower work yet.
How about if you have like the machines that do this steam for discotheques and stuff? It's like some kind of liquid that you
the vape pen hack. I do that constantly, but like I could add it to this, but then I'll have to like make a way for it to probably using a transistor. I could probably do it, make it blow out smoke, but then I don't know where I want the smoke to come out of. And that's like more weight you have to think about. So like I try to make this as simple as possible. And that's something that I constantly do is I will overthink things and make it super huge, but then you're not gonna get anything done because you've made it too huge. And there's no way you're gonna get all of that work done in a good time and put it all in there.
Yeah, but what I would think, if you want like a super fancy detailed steampunk stuff, then you could probably add like a fake steam engine with pistons and then like add this drive it with a motor and then just add this steam stuff to it, maybe.
I mean, yeah, I've already had that in concept for a while, but like that's later down the line. You have to think small, because if you go too crazy with it, you'll get nothing done.
Yeah, like me.
So how do you so since you like you don't just make robots, you make companion robots, which is really, really great because it's meant to give it, it implies it has personality, and that it's meant to be complementary to the person who made it, not just or is using it, presenting it, not just something. It's like, oh look, I made a thing that does some creepy identification or anything like that. But like, so how do you decide really like how it should, where it should go, or like how did you decide that the spider bot needed to be on your head? And actually, what is the name of that companion bot?
This one is called Paradoxy.
Paradoxy. Sorry, you definitely said that before.
Yeah, Paradoxy. Fun fact. Good example of that, because I have an art school background. Like I said, all the mechanical and techniques and stuff that I use is all like built. So I plan to mess with all the aesthetics, both cyberpunk, solar punk, all the punks versions pretty much. But the first thing I do is I always sketch things out. So like here's I'm not sure you can actually see it, but here's a piece of my sketchbook for the MK2 design, where I was trying to figure out like how it's going to move and things like that. I always like sketch everything out and kind of turn it into a character beforehand, before going out of my way and like trying to make it real. So like I think of how I'm going to wear it, where I'm going to wear it. Like I even draw myself sometimes for kicks and giggles and trying to figure that part out.
Wow, you're a really great artist as well.
I have a degree, but like
No, it's okay to be humble, but I find your idea of a sketchbook. I mean, mine looks like chicken scratch. Even like my try hard stuff looks like chicken scratch compared to your concept. So it's really great, and you can see like a clear through line of your concept to what you ultimately made, which is fantastic.
Yeah. Well, when it comes to like making a robot for me, I think of more of it as in character design concepts. So instead of you going in and thinking of functionality, which is I know this a lot of engineers do, you guys think of functionality before design. I think opposite. I think design before functionality. So I'm often thinking like, if this is a character or if this is a robot that is in like solar punk universe, how is it going to look? Is it going to have solar pads? Is it going to have green on it? Where's the green going to be? Where's this robot going to move? How is it going to move? How is it going to interact with things? And then I draw it up and then I design around that ideal. So like, if I want it to be solar powered, I'm going to add solar panels to whatever, and then figure out if they can be charged using actual solar panels. And that would be a fun little thing to have for it. Or if I think of, I'm going to have this robot, I want this robot to be like my kid's best friend. If I don't have a kid now, but if I had, hypothetically, if I have a child, and I want it to be his best friend, what type of design do I want to like give for my child? Like, I go through all those type of ideas before jumping in and getting to the design process. Yeah. And once I have ideas sketched out, that's when I go from like the sketchbook to the 3D CAD to Fusion 360 to printing out parts, testing fits, testing this and that and that and that. And so I get to eventually this.
Yeah, I mean, and that's great. And see, this is a really clear example of someone who is taking advantage of the kind of products like Adafruit makes, or and all the efforts everyone puts into trying to lower the barrier of entry for getting into electronics or making robotics or doing anything like that. Because it's a lot of people from the electronics side will say, listen, I have no design. I'm so focused on the functionality. I'm not really worried about what it looks like or anything like that. And someone who is the complete opposite, like yourself, that really benefits from that, and everyone benefits from that, because your linkages are so, like, the fact that that's driven by one servo is still just astounding to me.
That's something that's something I'm trying to push more in like the community, at least me personally, because when it comes to like sciences and things like that, I've noticed there's this type of like weird stigma to it that like, if you're going into this, you have to do something with it. Like, it's not like you can't just be a software engineer for kicks and giggles because you like to program. It's like you're a software engineer because you want this type of software job in the future, or things like that. And for me, I just want to show people that this can be fun. Like, you don't have to do this because like society says that you have to do this. You can just do it because kicks and giggles. Like, you guys watch a whole bunch of sci-fi movies. Why don't you want your own sci-fi robot? Like, WALL-E was a great movie.
Exactly.
You can go on to like millions of different like robot designs and different ideas, and then just realize that like this can be fun. It doesn't have to be just work all the time. Like, I get a lot of like questions like that on my Twitter feed sometimes, where people are like, okay, but what's the functionality? And I'm just like, fun. But what does it do? It makes things fun.
Yeah. Yeah, it's pretty incredible how many people don't seem to. I mean, from all circles, or like when you make something that's just aesthetically pleasing, or just like I said, just to make something that's cool or fun, they're like, but why? Like, but that is why. It doesn't need another reason. I just wanted to make this, and I'm like, oh, okay.
Yeah, I think the best example I've seen it before in like pop culture media is I own it. This is a bad movie, but it's one of my, what do they call those things? Guilty pleasure. Disney made a movie called Tomorrowland, which is like based off of their like theme ride thing. And the movie sucks. I'm not gonna lie, the movie's horrible, but I still like to watch it. But there's a part in the movie where like the kid actually makes a jetpack that kind of works. And then the guy asks him like, why did you make this? And he's just like, for fun. Like, if I saw this somewhere else, I would be inspired to make more stuff because he did it. And it's that same type of mindset I see constantly, where people are just like, what does it do? Why did you make this? If it doesn't do anything, if we're not making money off of this, why are you doing it? It's like, why can't I just have fun with it?
Right. Yeah.
Can you tell me, you must have researched different ways of attaching the robot to the human body, right? So
Yeah.
tell us a little bit about that.
Trial and error.
Right.
Trial and error are like my best friends in life. Like I've learned to test things out and see how things will go. And when it came to wearable robots, I started learning a long time working on Dexter back here, especially for like SuperCon. Taught me a lot about how wearables work when it comes to being on your physical form. So like this is so light that I can barely tell that it's here sometimes. If the servo wasn't moving, I would totally be like, there's nothing on my head. But I learned that because like when I was working on Dexter was super huge and super heavy. And when I tried wearing it on my shoulder, or like even with Aussie, I remember me and Alex Glow, when we did our first talk at Maker Faire in 2019 in San Francisco, after we did our talk and walked around all day with the robots on our shoulders, we both had shoulder pain. Like it hurt so much. And I've been expanding on that because like, if you want anyone to make a wearable robot, you want it to be comfy. Like you want, like you guys wear headphones constantly and headphones are comfy. Like you can wear them for hours without even realizing that you're wearing them. So I've been using that type of mindset when I go into like wearable robots because I wanted to make it as cool looking, of course. I want it to be aesthetically pleasing, no matter which aesthetic I choose that time. But I also want to make sure that it's comfortable. Because if it's not going to be comfortable, you're not going to want to make it. You're not going to want to use it. It's just going to be like a thing. But if it's comfortable and it looks cool, then sure, you might have like a free day and you're like, oh, I have to go to this party or something, or I have to go to like Renaissance Fair and I want a cool thing. Let me just take 2 days to build this really quickly. And then look, it's comfortable.
Right. Has anyone ever reached out to you about trying to turn one of your designs or seeing what you do and then reaching out and saying, hey, we'd like to work with you on making like a product or something like that, like something a little bit more mass manufactured? And if not, that's criminal that you haven't been. Absolutely.
Not yet. I mean, I've had, of course, random people like message me like, hey, I have an idea or like my type of thing. But I haven't had a real serious company come out and ask me that type of thing. Like, I make a joke constantly to my boss that there's only a few companies that I would leave my current job for. And they're all like Adafruit, like Hackster, like Instructables, those type of like companies who like teach and give out these type of ideas. But as for like, I work in manufacturing myself, but as in like mass production for like ideas and stuff like that, it's fun and it's great, but things always get icky when a dollar sign gets added to it.
Yeah.
So that's always the main issue I really have. Because like even taking this robot and like turning it into like molds and having it mass produced for things would take so long. It would be so like effort to be involved. Things on the side could happen, and then business people would get involved and have to worry about like lawsuits and things like that. And it's just, I'm just like, you know what? Let me just make this and then just give it out to the internet. Here, my children. Please have fun.
Right.
Go on to create. Inspire yourself.
Absolutely.
Like,
well, that's awesome, and I'm glad you're here. I'm sorry, Matou, you have to follow that, but you're up next.
Yeah. My mind is quite blown. So that's
it's okay.
Absolutely amazing. I love these robots, and I love this kind of inspiration here. They look so cool, and keeping to work on a project for a longer time, like that's super hard for me. I actually started the YouTube channel so I would have an incentive to finish 1 or 2 projects, and yeah, so I start a lot of projects, but I have difficulties finishing them. Yeah, so my first video was actually also about keyboards. I have this Keyboardio Model 1 here, which I love. But about a year ago, I've had this a while, and I had the issue that the key switches, they are actually a little bit too hard, so they required too much force for me to press them in the original key switches. So I decided to switch out the mechanisms, and since I did that and figured out how it worked, I thought, hey, why not make a YouTube video out of that? And well, that video was way too long and boring, but I still liked it, so I had fun with making YouTube videos. So earlier this year, I actually decided, okay, I had fun with this. Let's do a bit more. And I decided for this year, the rest of 2020, I think that was July or something, to to make one video each month, and I started with a 3D printable hydroponics system. I think I actually have a picture somewhere. Let me show you that. Where do I have it here? Okay, here we go. Yeah, so it looks like this. It fits into my 3D printer, which is an Ender 3, and there's a water reservoir in the bottom, and there is place for a growing medium on the top, and you can stick plants in, and every a few minutes water is pumped from the bottom part into the top and slowly drains back down again. And yeah, so that was my first video this year, and I kind of stuck with the 3D printing theme here. So what else did I do? So I think the month after that, Bleeptrack's Pico Planets actually appeared on Tindy, or she put her Pico Planets on Tindy, and I was working on making my camera drone autonomous. And when the Pico Planets dropped, I decided, okay, I really have to somehow include that into my current project. So instead of making them autonomous, I built a small remote, with Pico Planets, and I quite like this. So it works quite well. I think one of the joysticks. Wow. These are from the replacement joysticks for a Nintendo Switch, and I didn't have the right connectors in there, so one of them doesn't work as reliably. But yeah, that one was fun. I have a lot of duct tape on my project because somehow they never fit. So
hey, it's all good.
Yeah,
that's fantastic.
Yeah, so yeah, actually, yesterday I uploaded my newest video, which is kind of similar to the hydroponics thing. I built a water fountain for my cats, which are here in the background, currently sleeping and being behaving very nicely at the moment. Yeah, so that was fun too. Yeah, so but one other thing that was going on during this time was actually something that I wanted to talk about today, or tell you guys. Yeah, so I this year I participated also in the first South German 3D printing challenge, and so I think it was around January or something. There was this advertisements in buses around where I live. So I live in Ulm, in South Germany, and there were these advertisements for this 3D printing challenge where you could participate and hand in an idea for a 3D printable product, I think they called it. And yeah, I'm absolutely fascinated by 3D printing. About 2 years ago, I started playing around with a 3D printer we had at work, and started to print some cosplay props on that. And then that 3D printer got stolen, actually, and wasn't replaced. So I wasn't finished with my prints yet, so I had to get my own. So last year, I bought an Ender 3 and started 3D printing, and I'm so fascinated by this technology. So I kind of wanted to participate in that contest, but didn't really have ideas. But I talked to a friend about it, and he had a really cool idea. And so we actually decided to put something in together. And our idea was to take memories, for example, pictures or videos or audio recordings of something you did, I don't know, your wedding day or something, and use algorithms to generate 3D printable art sculptures from that. And when we do that, out comes something like this. So this is one of our algorithms that takes bits and bytes and turns them into trees. And the bits, they affect how the branches look. So how they're twisted, how long they are, I think for this model, that's all they do, but we're experimenting with the angles and different things. Another one that we did was a cube, which is kind of like a QR code in like layered QR codes, and looks a bit like this. And yeah, and we're still working on new things. So yeah, we thought, yeah, why not participate in that contest with this idea? And we didn't expect to get very far with it. So the contest was kind of aimed to making a business out of it, which wasn't our original goal. We just wanted to, have fun with it and try something new and experiment. But yeah, so we handed that in and made a small poster, and then a few weeks later, an email came. So hey, you made it to the second round, and now you have to make a business plan for this round. And Bitluni is laughing already. Yeah,
that goes from being fun to not fun.
Absolutely, we had that very, very same reaction, and so we considered dropping out at that point, because we looked at what they sent us. But then we decided, well, what the heck, we'll spend 3 hours on a Saturday to just come up with some numbers. So we took the template and just put in some numbers. And honestly, after I handed it in, I realized the numbers don't even add up. So we're spending money that's coming out of nowhere.
That's how hackathons work. That's how hackathons work. You just have to do a great pitch with nice music like Kickstarter.
Yeah. Yeah. So second part of the project, not as much fun as the first one, because first one coming up with these algorithms and actually printing the things, that was quite fun. And well, it took a while, but then after a while, we actually got an email, hey, you made it to the finals. And we did absolutely not expect that at that moment. So we hadn't seen anyone during all of that time, right? So the participation was online the whole time. So the whole pandemic thing hadn't really started yet, but I think it was in January. Everything was online. So we handed the ideas in online. We had email contact with the organizers. It was organized by the University of Applied Sciences in New Ulm, by the way. And so we wrote emails with them. And where was I?
Final round.
Right. So we hadn't really seen anyone. We hadn't seen any of the other teams. So by that time, we thought, well, we're probably one of the 2 teams who even participated in that. That's why we made it to the finals, because they just couldn't come up with any other people. And yeah, then the finals were supposed to happen in June, which wasn't possible because of lockdown here in Germany. Then they got moved to October, and they were supposed to be in person and live, but they last, I don't know, 2 days before the university there decided that they didn't want any events taking place there. So, but the organizers didn't want to move the finals again, so they made a huge Zoom meeting out of it. So everything was online. And there were actually, I think, 11 teams in the finals, 11 teams in the finals. And there were some really cool ideas as well. So there were some medical pliers and some makeup thing. And one team made a 3D print with chocolate, and the pieces coming out of there, they looked really good. I would have loved to seen that in person and maybe try one of those chocolate things. Yeah. So yeah, we were watching it. We were the last team to present our pitch. Oh yeah, for the finals we had to pitch our project to a jury, and So we were the last team to present our idea. So we were watching the others and were quite amazed by what the other teams did. Said, well, okay, we made it to the finals. It's fine. But then they announced the winners. So they went from last to first, and we weren't in there. And then came to the last three, and the last three was actually a live voting of the judges. And it was super close, but we actually won the whole contest with that. So that was super unexpected. And yeah, we were quite happy about this. And I think I have a few more pictures of the things here. Let's see. So yeah, so I have a bit bigger or larger pictures of the. So this is the cube that I showed earlier, with this QR code kind of way of encoding data, and the tree in its natural habitat in my in the backyard. We actually, I kind of like this one. So I printed some of the trees out of resin in a resin printer, and used transparent resin for that, and lit it from below. And those trees are tiny. They are like the smaller one is about the size, like the height, about the size of my thumb. So these are super tiny. It's fascinating how much detail you can get with these resin printers. And yeah, so currently we're trying to figure out what to do with this. We want to
follow your business plan, I would say.
Yeah, our business plan. So we might actually we're actually thinking about making product out of it. So we want to definitely make some of these algorithms public, and we don't quite know yet how we will exactly proceed, but it might. So we would love to make these in a really nice quality. Like, for example, the tree. So this is the bottom half is actually printed out of PLA, and the top half is resin. I started printing this in PLA, but printing this with supports, I wasn't able to remove the supports without breaking the whole thing. And then I started to print it in parts. So I, each branch by itself, but the printer started tipping over the branches while they were printing. So I used the resin printer instead and glued everything together, and then colored it. But we would love to make something like this out of metal or maybe wood or some nice material, because taking your memories, your pictures, and putting them into art sculptures, I think that should probably be something that lasts a little bit longer, that's a bit more sturdy. So since that would probably cost quite some money, we might actually make a selling product out of that, but we would love to have the algorithm online so people can generate these things for themselves, and if they would like to make it or 3D print it themselves or somehow modify them, we would be very happy to see people using that.
There is maybe a possibility that already we're using stuff that's already there, because you have in photo studios or shops where there is this stuff where they laser 3D scans into a plexiglass cube or something like that.
I know what you mean.
You could probably just your generated shape. You could probably just use that and laser it into one cube. And your stuff, the simplest way selling this is to sell the software and using starting with lasering it into a cube or something. So
that's a pretty cool idea, actually.
Yeah, that might be a starting point.
How big can you make these cubes? I've only seen like tiny ones in the photo studios.
5 centimeters square.
Yeah.
No, something like that.
At some point, I'd love to see like a, I don't know, 2 to 3 meter tree like this or cube like this. That would be really cool.
Yeah.
All right. Yeah. So
Interesting
that
story.
was
Did you win something?
Oh yeah,
dude, that was awesome.
we won a lot of business stuff, so coaching for the business and no, but some really cool things too. We are supposed to get a trophy, which I love, and I have a picture of that. We have received that because the finals, the whole event was online. But this is what the trophies look like. And so they're 3D printed as well. The base is CNC'd, I think, from probably aluminum. I'm not sure. And the top is 3D printed. And if I got that correctly, it's actually 3D printed from metal and then colored in the gold, silver, and bronze. So, but I'm really looking forward to seeing this in reality because they look really cool, I think.
Oh no, there is no real thing. Since it was virtual, you will get only the STL file.
Oh.
Have to make it yourself. Have to put your own award.
I have a question about one of your other projects about the hydroponics. What I experienced when trying to print something that's working with water, it was never watertight. So you have always like to treat it with paint it or whatever to make it. Were you able to print something that's really waterproof?
No, I tried. So I tried different models. I think all of the things I tried were PLA. I don't think I've tried any other material. But I couldn't get anything waterproof completely. So this is coated with resin. The reservoir is coated with resin, and the top I've actually put some. I think I cut up a trash bag and duct taped that in the top part.
Okay, cool. Yeah, I was just wondering. I think even PLA, it would soak up water. If you have like sitting water in PLA, it would probably
that's a problem with the spools, right? Like
Okay, cool.
That's awesome. Well, great. We have lost Clem. He sent me a message that his ISP has decided not to do what he's paying them to do anymore. So he said goodbye and good night. So it's the 5 of us for the rest of the evening. And I just like I said, I didn't have that much going on this month. I did have a couple of things planned, but a lot of things came up all at once, and just nothing came together. I did get Bleep Tracks Touch Planet thing, generative art, which is awesome. I meant to get it set up today, but I forgot that my wife had a thing going on. I didn't have time to do it. But so instead of talking about myself, I wanted to go ahead and show a couple of things some people who've been on the past have going on just real quick. Starting with Blitz City DIY, The Legend of Frank. Let's see if I can. There we go. Push the right button, rearrange everyone correctly. Which is a project she was working on most of October, and it's a pretty cool Frankenstein build, mostly 3D printed, and it does do some things that I have totally blanked out on. But it's a really cool build. The video, you're going to get a political ad. So while that's going, let me show you what Steven has been working on, his pick and place feeders. I've been following his pick and place project for a while now, and I'm actually pretty excited to every time he puts out an update. I couldn't be more excited to see it. And he's actually had an ongoing chronicle with the pick and place feeders. I think that's one of the areas he's done the most iteration on of late. So be sure to check that out. And Brian, frequent guest on the podcast, released his USB-C power delivery adapter so that you can power your various projects with just like a power bank or over just USB-C in general, but allowing you to control the voltage and everything like that for your project boards. That's a really great thing, really cool project. So be sure to check all that out. And does anyone else have any other projects they might want to shout out that's not maybe theirs personally, but a pretty cool one? Oh, no. Let's see. So she shows her doing all the design for it and everything like that. Various 3D printing iterations and everything it does. It's a really cool Halloween project. A good distraction for everything going on in the world. So be sure to check out Blitz City DIY's video. I'll put the links in the description below. And yeah, is there anything else? Anyone else has any questions for somebody or?
I have a mini question. How long do these podcasts usually last?
Well, when I'm on, too long. but usually about 2 hours. 2 hours.
Oh, okay.
And the longest. Yeah. So now typically there's supposed to be quizzes, which I didn't bother putting together because I kind of forgot about it. So we'll just go over some just a couple of quick questions. Which would you rather do? Complete one project or start a dozen?
Oh, if I'm going to go, I'm going to say complete one, because starting a dozen means you get nothing done. Wow, congratulations. You have a whole bunch of extra work you have to do that you're never going to finish.
Yeah, I'm definitely a complete one. I can't, I don't like having unfinished projects. It eats at me. It literally eats at me until I finish it.
I have a rule that I have multiple projects, but I have one focus. So I can be working on 10 projects on the side, but I'm focusing on one.
Right. Bit.
So how do you do that actually? So what does it mean? Focusing on one? How do you make
well, so for me, it means that whenever I get an idea that makes me want to stop what I'm currently working on and do something else, I just write it down and go back to it in the later. Because so finishing a project doesn't necessarily mean I finished a project. That can also for me it means I got to a point where I can't go any further with it.
The
I hit a dead end.
rule.
Right. Yeah. I hit a dead end where my own abilities or oh, this is going to cost way more than I thought it was going to cost. So it gets thrown. It gets set to the permanent back burner. Or with my badges, most of the time what happens is I get about a little bit past the concept phase where I'm actually trying to prototype it, and I figure out that there's going to be some insurmountable difficulty or something that's going to make it impractical, and at that point I drop it and go to the next thing because I know that it's not really worth the effort, because I'm not making a video about it or anything either. So I don't feel like I'm accountable to anybody other than myself, which is also why sometimes my Twitter goes dead because I'm not talking about what I'm working on, because I don't want people so what happened to that clock thing you're working on? Oh, well, you see, it turns out designing a clock pretty difficult. Who knew? But so does that mean you were definitely a start a dozen projects?
Well, I don't want to be. I want to finish projects. Starting a YouTube channel has kind of worked in that direction. I've already told you about that before. So that's been definitely a good thing. I've something to work towards too. But the thing with me is, once it's kind of done, I lose interest so quickly, or it's like I sometimes come back later to this idea. For example, the hydro thing. I built it, I printed it, I shot it, I edited the video, and then I just didn't want to have anything to do with it anymore. It just sat there, and and
YouTube.
That's the other side of that, right? And that's why I like to. When I finish a project, whether it actually produced something or whether I just stopped it because it wasn't going to work for some reason. That's part of the reason I do that, because I had the same mentality. When I'm done with something, like even like a finished project, like my badges and stuff, like I don't want to talk about. I'll talk about this, but I don't want to make another one ever again. So I might want to make an iteration on this, or because of course, like I have the same problem every person who makes anything does. Is all I see is everything I did wrong with it. Every little thing that's wrong with it. Every way it could be better. But that's also why that can be a trap of constant iteration on something. And especially if you're like a content maker, you might want to do something because people get bored of it. But I mean, no one gets bored of robots or companion robots. So
yeah, that's
I'm sorry, I don't have that problem. Like I sketch everything out in my sketchbook, but I have also a list of projects, and I kind of go down the list. So like if I'm waiting for a project to finish printing, or I'm waiting on something, I'll go into my sketchbook and secretly start planning out another project. And then let's say if this one's technically done, and now I'm doing is testing it now, I have another print going on for my next project.
Yeah,
I'm constantly iterating and things like that. And I don't even see failure as a bad point. Like I see you guys say you see your mistakes. I see all the things that just didn't work. It's kind of like, I guess the best way I can describe it is like, this is a horrible example, but I'm going to use it anyway. It's like watching your kid grow up, or like a cat or something like that, or something you care about grow, for the fact that you're going to see all their mistakes. But if you continue working with them and working with that, you're going to see all the greatness that comes out at the end of it. So I don't really pay attention to most of my failures. I'm just like, oh, that didn't work. Well, that was fun. Gonna sleep on it and get back to it tomorrow. But I'm constantly obsessed with my projects. Like this was a month of me non-stop building, and this has just been like a labor of freaking fun. Like it's been great every second of every step of every way. And I already have several more robots to be getting down to once I get to this point. And it's just fun. Don't tax yourself on making content and stuff like that. I know you might have to, because a lot of times people use YouTube to pay bills and stuff, but don't forget why you started in the first place. You were probably at one point smiling and just enjoying it and just having fun. Don't forget that feeling. Don't forget how fun this was.
I put the hydroponic system in a less accessible room because the kittens, they tried to play with the growing medium, and I was afraid they would eat it. So I put it away, and it's automated. So I connected it to my Home Assistant instance, and so it's watering the plants every 10 minutes, and I just have to put in some water every once in a while. And I pretty much forgot about it. And then last month I actually went into that room and was really shocked because the plants got so huge. They seem to like it.
Right. So Bit and Deshipu, where's your take on that? On the complete one or start a dozen?
So basically everything was said. I would say I want to start 10 projects. I would like to finish one, but it's always so painful. We had this Pareto rule, 80-20. 80% is done in 20% of the time, and the last 20% is 80% of the time. And making YouTube stuff, if you want to, or publishing anything, if you want, you need to get this extra mile to stand out, and that's very painful all of the times. So every time I really feel it. If you say, when I finish something, I just put it away and want to never do anything with it anymore. So because you, like when I edit videos and I do it for days and sometimes even weeks, and I saw the one specific scene 100 times or even more often, I hate the video after I'm finished.
Well,
And then-
I think that's a requirement to hate what you made when you're either when you're done with it or nearly done with it.
Yeah, but then after some time, you watch it and you see, oh, it was actually better than everything I do right now. So, but I think what Jay said is right. Remembering why you did it or why you started it. So it's like if you're passionate about something and you're curious and want to learn things, I would rather learn 10 new things to a certain degree instead of perfectioning one thing. So I don't want to be like a nerd in one thing. I'm curious about all the things, and I want to do them like maybe even only 20%, knowing how something works. But I'm rather interested in many things that I want to try, and that's how it is for me,
Right.
at least.
Deshipu, what's your take?
Well, I don't even understand what it means to finish a project. I mean, my projects will be finished when I'm dead. Until then, I keep seeing new things I can improve. I keep seeing things I can, there is always even a little thing that you learn after 2 years, and you could, remake that one little detail.
Yeah.
And so it's never really finished. So projects are forever. Be careful what you are starting.
Yeah. I mean, but that's kind of the part of the, it's like the, part of the reason I like to do such really different things, one project to another, if I can, is mostly because I'm trying to learn something new, and it might not even be the thing that I'm making. It might be the process that I'm using to make it. My first year making a bunch of circuit boards, I did everything by hand, including soldering everything. The second year I did everything. I incorporated stencils and reflow ovens and things like that. This year was hypothetically going to be the year I started looking into, or more seriously doing, PCB assembly and such, contracted PCB assembly and such. And this was actually the first year that I had really experienced genuine, just terrible burnout. And it was because I had started on a project that, I got invited to do a project that had a really, really incredibly short lead time. And we were about 50% done with the project when China shut down for COVID. And we were supposed to do everything for the project in China, including go to China for the event in China. So when we got the news, I was kind of like, oh, okay. And at that point, everyone was, we didn't understand the severity of the situation. So everyone was like, okay, well, we'll keep working on this and chugging away. And then we'll see where we're at in 2 months. So we kept working on it. And then that 2 months came, that point came, and things were, where they were, definitely not better. And eventually, of course, we, the whole event and everything got canceled. But the intense buildup and sudden wall stop just killed me. I did almost nothing creative for a couple of months because it just it just like there's other things, it's the other side of that. It's like there's more important things to focus on, and this year has definitely been a challenge, and for a lot of people, for everybody, not even like just everybody's had a rougher than normal year, and being able to get back onto projects and working on them and doing things and sharing things has really been a great distraction. It's awesome being able to learn something new and focus on it.
Just adding on to that, like at least a way that helps me, and I'm pretty sure it helps a lot of people too, is just share a little piece of it with the community. Like I love when I'm like still working on something and I post it on Twitter and I'm just like, hey, this is where I'm at right now. the community is so nice. Like, you guys are kind of like one of the best communities, in my opinion, that when it comes to things like this. Because, like, I can post like, oh, I totally messed up. This didn't turn out how I want to be. I feel bad about it. And I get like several messages on my Twitter feed like, it's okay, things are going to be better and stuff like that. Like, don't be afraid to fall back on the community. These are decent human beings most of the time. They're decent human beings. So just, like, it helps. It helps to have that pickup from other people, even though they might be complete strangers, even though they might be fans or just some who knows who. But just having that little like extra help just can take you a long way.
Yeah, and sometimes they can get you over the hump of a simple problem where you don't quite know. You know what the problem you have, but you don't know the terminology, or that's an entire industry is dedicated to that problem. And someone goes, "Oh, hey, look at this. This might help you out." And you're like, "Oh, shoot, I've been stuck here for 2 weeks. Great, now I have a new rabbit hole to dig into." But it's very helpful. And like I said, you only get that really if you're open and sharing and showing people what you're working on and at the various stages.
That's actually true. Live streaming is really helpful. I got so much help from the awesome guys there. They're geniuses that are watching, and they know, like, in 5 seconds you get the right answer, or they help you find something on the webs or something if you're doing it live. That really helps. So I'm enjoying with the core of the people that are following, enjoying developing stuff and debugging stuff live on stream. That's actually cool.
Yeah, and it's the thing that keeps getting said every this year is we're all in this together, and I was like, we've always all been in this together. that was never not the case, but in that way, share what you know, and be humble. Don't no one knows everything. I think the most difficult thing I've had to come to terms with as I get older is how much I can't know. Like, it's just not possible for me to know these things while also being a productive member of society. But yeah, well, with that, I think we're gonna wrap it up here. Thanks everyone for coming. Clem is no longer with us because his ISP is not cooperating. But Ajay, Matou, Bitluni, and Deshipu, thanks for coming. Thanks for sharing everything. I guess the next episode will be December 6th. That's the first Sunday in December.
Yes.
So look out for that. Thanks everyone who was joining us in the chat and everything like that. Have a good weekend. Be safe and take care of yourselves. Goodbye.
Thanks for having us. Bye.
Later.
Bye-bye.